All right, ready to dive into some seriously cool physics today. We're going to be looking at how pressure and volume work together, especially when it comes to diving.
And the best part is you don't have to be a physics genius to get it. One of the most interesting things is that these pressure changes, they mostly affect gases, not so much liquids and solids.
Okay, so why is that?
Well, liquids and solids, they're just way harder to compress. Like picture a scuba tank, right? It's got those super rigid walls. The volume inside that tank, it's staying the same no matter how deep you go.
Yeah.
But imagine if you brought a balloon down with you.
Oh, yeah?
That change in pressure, you'd really see it then.
Right, because a balloon, it's flexible. So deeper you go, more pressure, the balloon shrinks.
Exactly. And then the reverse happens too. When you come back up, less pressure, balloon expands back to its normal size. It's all about how the gas inside reacts to those pressure changes you see.
You know, that makes me think of something like when you're on a plane or sometimes even driving up a mountain and your ears pop.
Oh, I feel
That's got to be our ears reacting to the pressure changing too, right?
it is. And it all goes back to, well, there's this fundamental law in physics called Boyle's law.
Okay, hit me with it. What's Boyle's law all about?
So Boyle's law, it basically says that if you multiply the pressure of a gas by its volume, that number, it's always going to stay the same, as long as the temperature is constant, of course.
So if one goes up, the other one goes down, like a seesaw.
You got it. Okay, imagine this. A diving bell. It's like a giant upside-down cup that you lower into the water. Let's say at the surface, it's got a volume of 1 cubic meter. Now, you take that bell down 10 meters below the surface. The pressure there, it's double what it is up top.
So the air trapped inside, it would be swished, right?
Right.
Down to half its size, half a cubic meter.
You got it. And this is a big deal for divers, especially those first 10 meters of depth.
Why are those first 10 meters so important? I mean, the pressure keeps going up the deeper you go, right?
Yeah, but those first 10 meters, that's where you see the biggest difference in pressure. You're going from 1 atmosphere at the surface to 2 atmospheres just 10 meters down. It's a 100% increase.
Whoa. Yeah, that is a big jump. And then after that.
I mean, the pressure keeps increasing as you go deeper, of course.
Right.
But that relative change in pressure every 10 meters, it's smaller. So those first 10, that's where it's most dramatic. For your lungs, for example, really for everything. Knowing this stuff, it's crucial for diving safely.
Makes sense. We always think about the big picture changes, but it's those smaller, more immediate ones that really matter, huh? So what happens if you push those limits?
Well, that's when things can get a little dicey. Think back to our balloon example.
Okay, back to the balloon. So what happens if you push those pressure limits too far?
Well, we know a balloon, or any container really, can only handle so much when it comes to pressure and volume, right? Like if the pressure outside drops too fast,
Let me guess.
say if a diver comes up too quick.
Boom, exploding balloon time.
Exactly. The gas inside is trying to equalize so it expands super fast.
Okay, that makes sense. But what about the opposite? What if the pressure outside goes up too quickly?
That's when you get an implosion.
Yeah.
That outside pressure, it's just too much for the container to handle, so it crumples in on itself.
And that's not good for divers.
Yeah, you could say that. That's why divers have to be really careful about how fast they go up and down. Too much internal pressure or not enough, both are bad news.
So it's all about finding that sweet spot, avoiding the pop and the crunch, I guess you could say.
Exactly.
But, you know, thinking about pressure and volume affecting things, it's not just about what happens under the sea, right?
Hmm.
This document, it mentions some other examples.
Oh, yeah, for sure. I mean, these principles, they pop up everywhere. Think about something like weather patterns.
Okay, yeah. How does that work? Pressure and volume with the weather.
Well, at its most basic, weather, it's really just air masses moving around.
Hmm.
And those masses, they rise and fall because of temperature differences, which then impacts pressure.
Right, because warm air rises. So as that warm air goes up, it creates lower pressure.
Exactly. Warm air is less dense, so up it goes, and you've got yourself an area of low pressure. Then that cooler air, the denser air, it rushes in to fill that space. And that movement of air, that's what we feel as wind.
Wow, okay.
But there's more to it. Remember Boyle's law. So as that warm air rises, right, and the atmospheric pressure drops, the air expands, which then really gets those weather systems going,
So it's like a chain reaction?
pretty much.
So Boyle's law, it's not just for diving bells and balloons. It's playing out on a huge E scale with the weather we experience every day.
You got it. And get this, it even applies to everyday stuff like cooking.
Okay, hold on. Cooking. You got to explain this one.
All right, picture this. You're baking a cake.
Hmm.
The recipe, it always says what temperature, right?
Ooh.
And sometimes even how long to bake it depending on your altitude.
Yeah, that's true.
That's because the pressure and volume, they're actually super important for how that cake bakes. See, the heat from your oven makes the air bubbles in the batter expand, and that's what makes the cake rise. But at higher altitudes, you've got lower atmospheric pressure, which means those bubbles, they expand even faster. And that can totally change how your cake turns out if you don't adjust the recipe.
Wow, I have never even thought of it like that, but it makes total sense.
Or think about a pressure cooker. The whole thing works because of pressure and volume. You trap the steam in that sealed pot, the pressure increases. And that higher pressure, it actually makes water boil at a higher temperature, so your food cooks way faster.
So we're just using physics to make dinner quicker.
Exactly. And that's what's so cool about physics. Those basic principles, they're at work all around us, even in places you'd never expect.
It really is amazing when you stop and think about it. This deep dive has definitely made me appreciate these concepts in a whole new way.
Well, we've covered a lot of ground today, from diving bells to exploding balloons, even baking a cake. Pressure and volume, it's everywhere.
It is. And I think what gets me most is understanding this stuff.
Yeah.
It can really empower you in everyday life.
What do you mean by that?
Well, it's not just about, memorizing Boyle's Law or whatever. It's about actually seeing how those pressure and volume changes, how they work in the real world,
Yeah.
and then using that knowledge.
Right, to make better decisions.
Yeah.
So whether we're diving, cooking, or just looking at the weather, this knowledge, it helps us really appreciate what's going on.
It's like, having the cheat codes for how the world works. And when you get those basic principles, then you can start to predict stuff or even control things to your advantage, like we do with the pressure cooker.
It really shows how everything is connected, you know? I mean, who would have thought that the same thing that makes a balloon shrink underwater also affects the weather? It is kind of beautiful, isn't it? This elegance to the natural world, these basic laws, they're running everything.
Yeah.
From, the tiniest atom to the entire universe.
Well, deep divers, much as I'd like to keep going with this, it's time for us to surface from this deep dive into pressure and volume. But before we go, our expert has one last thought to leave you with.
So we talked a lot about how pressure affects gases, right? But what about liquids and solids? We know they're tougher to compress, but is there ever a point where even they change under enough pressure? Like, think about deep down in the Earth's mantle, or even the core of a star. That kind of crazy pressure, what does it do to matter? Something to think about.
Wow, yeah. That's a real head scratcher to end on. It seems like there's always more to discover and learn. Thanks for joining us on this fascinating deep dive, everyone. Until next time, keep those brains bubbling with curiosity.